This is Chapter 7, High-Rise Building Fires. The objectives of Chapter 7 are to understand and explain why high-rise buildings present a difficult and different fire problem for firefighters, including the unique fire behavior problems that may be encountered in a high-rise fire. Recognize the difference in construction methods of high-rise buildings and explain how different construction materials and designs impact fire behavior in these buildings. To describe the firefighting strategies and tactics used to locate, confine, and extinguish high-rise fires. Describe the special problems that may be encountered on high-rise fires, such as communication issues, the stack effect, ventilation concerns, evacuation issues, and elevator control. To describe and explain the purpose of special fire protection equipment which may be found in high-rise buildings. And finally, to describe when a stairwell support system may be needed. Development of vacant land in large cities has resulted in a tremendous increase in property values. As the amount of available land becomes scarce, the cost of land increases, resulting in building developers building upwards rather than purchasing additional land to build horizontally. This upward growth has resulted in high-rise buildings, which are defined by the National Fire Protection Association Standard 101 Life Safety Codes as buildings more than 75 feet in height, where a building is measured from the lowest level fire department access to the floor of the highest occupiable story. There are variations in code definitions of high-rise buildings throughout the country. For firefighters, the best policy is to check locally for appropriate code to obtain a better understanding of the code specifics. Almost all of the definitions indicate that these buildings have floors higher in reach than fire department ground ladders. This requires fighting the fire from inside the building. Upper floor fires present firefighters with a different set of problems than those encountered in buildings that they can easily and quickly be reached from ground level. While the basic firefighting tactics used on high-rise fires are the same as those used on most other structures, these buildings present special considerations and problems. The building may contain multiple occupancies, such as apartments, commercial stores, restaurants, and extensive parking facilities. The height of the building presents an opportunity for greater smoke movement within the building. All firefighting equipment, supplies, and human resources must be delivered to the upper floors, a labor-intensive task that requires additional personnel. Access to egress from high-rises can be difficult under emergency conditions, as occupants and firefighters are required during some emergencies to use the same stairwells to exit and enter the building. The HVAC systems can, if not properly controlled, assist the spread of fire and smoke to other locations in the building. Because of these significant differences, a description of the fire problems and fire behavior of high-rise buildings is of special importance to firefighters. According to the National Fire Incident Reporting System, NFIRS, for the period from 1996 to 1998, there were 15,500 high-rise fires in the United States. These fires resulted in $252.3 million in annual property loss and 930 civilian injuries, including 60 civilian deaths. While 75% of these fires were in high-rise residential properties, they caused only 25% of the total dollar loss. The main reason for this is that high-rise residential fires tend to be contained within one room, whereas 75% of the fires in high-rise manufacturing, industrial, and storage buildings are not contained to the room of origin. Occupants of high-rise buildings face several important issues in terms of fire behavior and safety. These issues include the manner and materials of construction, as well as the building contents. Firefighters categorize the construction materials and designs of high-rise into three major time periods. Each time period has a distinctive construction design and use of construction materials. This picture illustrates the dangers that could be encountered when faced with a fire in a high-rise building. I don't know about you, but I wouldn't want to be going into that building. Structures built from 1870 to 1920 were constructed with little or no concern for fire safety. At the time, there were no standards for the protection against heat for buildings' steel components. When heated to a little above 1000 degrees Fahrenheit, steel quickly uses its strength. Steel also expands at the rate of 6% to 7% for each 100 degrees Fahrenheit. This means at 1000 degrees Fahrenheit, it will expand about 9% for each 100 feet in length. In a masonry building, where steel beams is blocked by a wall, the steel can cause a partial or total wall collapse. Some of these early buildings were built with floors supported by concrete piers, which created an open void space where fire and heated gases could move underneath the structure. To prevent fires from spreading from these open spaces, some building contractors used terracotta tiles to provide fire resistance. These tiles were effective as long as they did not contain holes or poorly cemented joints. This would create open spaces and allow fire to spread. Most construction work used the least expensive materials and workmanship that was of poor quality, resulting in a fire which would quickly spread throughout the entire building. Some of these buildings were equipped with standpipes, but most water supply lines were too small to effectively deliver the amount of water needed during a fire. Pre-incident planning is recommended for jurisdictions that have older buildings remaining. Careful planning and risk assessments should be done as well. Buildings constructed from 1920 to 1960 have important fire safety features that were lacking in earlier buildings and have some features that are not found in newer high-rise buildings. These buildings were framed and tiled with concrete or masonry, which was used for fire-resistant protection. Concrete steel reinforced columns that were spaced about 30 feet apart supported the floors. Each floor was served by several widely spaced concrete encased steel stairwells. The windows on each floor could be opened, allowing firefighters to ventilate. Many of the windows leaked air, so movement was within the immediate floor rather than throughout the entire building. A good example of this type of building is the Empire State Building, which was built in 1930. Its thick masonry walls resulting in the building weighing about 23 pounds per cubic foot, while newer high-rise buildings using drywall are approximately 7 to 8 pounds per cubic foot. The added mass will absorb more heat from a fire than the lighter built building. Buildings constructed after 1960 are the modern steel and glass buildings that can be found in most downtown areas. These buildings differ from earlier high-rise buildings because new construction materials, methods, and systems. They use gypsum wallboard and light white concrete for fire-resistant protection. They also contain central core construction and use central heating units, ventilation, and air conditioning systems for heating and cooling. The product called gypsum board has gypsum material pressed into its sheets, 4 feet by 8 feet or 4 foot by 12 feet in shape. The gypsum is held in place by 2 pieces of heavy paper to give it shape. The board can be nailed to wall studs or fastened with screws into metal studs. It is relatively light in weight when compared to other concrete products, but the strength quickly fades when material is wet or suddenly hit. On September 11th in the World Trade Center, sheets of wallboard were knocked off the stairwell walls by the impact of the aircraft. This event caused the displaced sheetrock to block stairwells and trap persons by blocking the movement up and down the stairwells. This week's video will go into more detail about that. Firefighters use a coating of concrete called lightweight or blown-in concrete to help protect steel and structural components and fire-resistant properties. This type of concrete material contains additives to increase the heat resistance and to adhere to the steel components. The purpose is to insulate the steel from the effects of the heat and fire. The thickness and the ratio of the concrete to trapped air determine the fire resistance. A variety of these materials are available and sold under various trademarks. Like gypsum board, after September 11th, questions was raised about the application process and the poor adherence of the lightweight concrete that had been used to protect the steel floor truss components from the fire and heat. New standards for application methods of material are being considered. Also found in the post-1960s high-rise is the central core method of construction. In the pre-1960s construction, exits could be found on every floor, remotely located from each other, and in most buildings, one exit in every corner of the building. These exits served as a stairway to the first floor or a floor that contained an exit directly onto the street. In contrast, the 1960s central core construction buildings place the elevators, stairs, and restrooms in rooms containing the building support systems at the center of the building. Thus, all the plumbing, telephone, and electrical systems could be channeled within the utility chases centrally, reducing material costs and installation costs, as all of the plumbing and wiring were centralized in one location. One problem is that the vertical channels now provide an excellent method of travel for fire and toxic gases. Likewise, exit stairways can be constructed at less cost if some of the walls can be used as common walls for elevators and other exits. The idea is to centralize these common requirements in the center of the building, leaving the outer portions of the building available for lease. In high-rise buildings, the HVAC system must be shut down during a fire or designed with features to protect the system from moving the fire from floor to floor. Fire dampers are installed in the return duct to prevent fire and heated gases from being circulated into other parts of the building. Firefighters need to know the location of the fire dampers and to follow up and make sure the fire and smoke is not being circulated or spread to other parts of the building when they are activated. After fire has been extinguished, firefighters need to ensure that the fire dampers will be reset for future operation. The systems in some buildings can be configured so that the total system or the zone within the building can be used to exhaust smoke from several areas and supply fresh air to an area in the event of a fire. This requires a thorough working knowledge of the specific building system and a detailed knowledge of how these systems function. On the other hand, some systems must be shut down immediately, as it will spread fire and smoke to unaffected portions of the building. Information about the HVAC system should be discussed with building maintenance service, and written operating details should be obtained during pre-fire planning sessions. This illustration shows you the central core floor plan for high-rise buildings in modern-day high-rises. The stack effect is a natural movement of air within tall buildings caused by the temperature difference between the outside and the inside of the building. This temperature difference causes the air in the building to rise and fall and varies with the amount of temperature difference. The air movement becomes very noticeable in buildings over 60 feet high and becomes stronger as the building gets taller and the temperature difference becomes greater. This pressure difference forces heated air in the structure at lower levels up to upper levels until this lighter, heated air reaches a point in the building where the air temperature is equal and the weight of the air is balanced. The area in the building is called the neutral plane or stratification location, in which the air flows upward and then flows horizontally. For firefighters, this means heated smoke and fire gases will begin to move horizontally, resulting in lateral fire spread. In most cases, it occurs at or close to the middle of the building, as the pressure differences balance out. This illustration shows you stratification inside a high-rise building. The smoke and hot gases rise in the high-rise until they get to a point where the same temperature and weight of the surrounding air matches the inside and the outside of the building, and that's where the smoke and fire will tend to stay, and this can spread the fire and smoke laterally. Ventilation is the planned and systematic removal of smoke, heat, and gases from a structure. The reasons for ventilation are to remove toxic gases and to eliminate hazardous health conditions for the occupants and firefighters. This will allow firefighters to locate the fire more quickly and reduce fire and smoke damage. The traditional method to accomplish ventilation at fires are opening or breaking windows, bulkheads, and scuttles, or cutting a hole in the roof. These methods are not always available on high-rise buildings. In newer high-rises, ventilation is more complex, as most buildings are sealed. Furthermore, these buildings built in the later part of the 1960s and 1970s will probably not have an HVAC system configured to exhaust fire gases and smoke. Therefore, if horizontal ventilation is not an option, then an enclosed stairwell can be used if it's not being used for occupant egress or firefighter access, and if it contains an opening that can be used to safely exhaust smoke. If a stairwell is available, Then the door on the fire floor onto the stairwell is to be held open, and an exhaust fan is used to direct the smoke up the stairwell and through the enclosed shaft and out of the building in a safe location. All intervening floors are not impacted by the fire, must be closed, and all other openings should be closed so that the fire and smoke will not spread to other areas of the building. This operation must be carefully planned and checked continuously for unwanted fire and smoke spread during the progress. Some newer buildings are equipped with fans that create positive air pressure in the stairwell. These systems can be used, but with great care and caution, as pressurized air can move the smoke and fire to uninvolved portions of the structure. This is as an important feature to learn about from the building engineers and maintenance personnel during pre-incident planning visits. A key component to efficient high-rise fire operations is the safe and reliable use of elevators to transport firefighters to and from their fire location in the building. However, we know from past experiences that elevators have malfunctioned during emergency operations, resulting in the death of civilians, building security personnel, and firefighters. Generally, firefighters will attack a high-rise fire using the stairwell on fires occurring on any of the first 6 floors. Fires on lower floors do not warrant the use of an elevator, unless its safety can be verified by sending a firefighter to the fire floor, where the elevator can be inspected for safety concerns. When the incident is higher than the 6th floor, most fire department policies allow the elevator system to be used, only after confirmation of the elevator's safety. A recent report by the National Institute of Standards and Technology concluded that after traversing more than 20 floors, firefighters were so fatigued they were not prepared for fighting the fire once they arrived. This finding confirms the importance of developing methods and procedures for firefighters to safely use elevators. Some departments allow elevators remotely located from the fire to be used if there is fire suppression between the elevators and the fire area. Firefighters using these elevators move the personnel and equipment to the floor below the fire, then ascend the stairway 1 floor, and travel horizontally to the fire. This approach is much safer and easier than ascending multiple stairs. It also keeps firefighters that are loaded down with heavy, bulky equipment out of the stairwells where civilians may be descending to exit the building. An understanding of local fire department policies and procedures is important when regarding if and when elevator use in high-rise firefighting is safe, and when will it be permitted. Firefighters' death and injuries are responsible for laws being passed requiring the installation and retrofitting of fire service override system in elevators in newer high-rise buildings. These systems provide manual control over all automatic elevator control cars, providing greater margin of safety for firefighters and building occupants. The standards for fire service and elevator safety are in the American Society of Mechanical Engineers Code. They provide for uniform standards throughout the nation for newly constructed systems during installation and when older elevators are upgraded. By installing the firefighter's key system, the system is taken out of the automatic operation and placed under manual control of the firefighters. The manual control is divided into 3 phases. Phase 1. This is sometimes referred to as the firefighter's recall. This brings the cars non-stop to the lobby or pre-designated area and automatically opens the doors. In some systems, the Phase 1 operation can be started by the activation of a smoke detector in the building. The purpose is to ensure that the building occupants use the stairways and to prevent the car from stopping on the fire floor. Finally, it does not allow the doors to open automatically. Phase 2 is the operation of the fire service controls in the elevator car. This phase allows firefighters to manually control the elevator from inside the car. The lobby key in Phase 1 cannot override the key operation in the car. Many departments have a standing policy prohibiting the use of elevator cars that does not have Phase 2 fire service controls. Phase 3 is connected with the building's fire and smoke alarm system and applies when fire or smoke alarm is activated. If the smoke detector activates in the lobby, the elevator cars will not return there, but will be recalled to a pre-designated floor other than the lobby. Firefighters will have to go to the designated alternate floor to get in the car. The location of the car can be found by viewing the panel in the lobby. During the pre-incident planning walkthrough, this should be checked and noted in the building pre-incident planning document. In most high-rise buildings, the occupants are generally mobile and are able to use the stairwells to exit the building on their own. However, the congestion of firefighters moving upward into the building while occupants are attempting to evacuate reduces not only the firefighters' movement, but also inhibits the escape of the occupants. One way to avoid this problem is to designate one or more stairwells to the occupants' egress and one or more stairwells to the firefighter operations. Elevators should only be used if they are safe. If not, a stairwell support procedure must be put into place. Using this procedure, firefighter teams are stationed 2 floors apart in the stairwell. The first team carries the equipment up 2 floors to waiting firefighters, who carry the equipment 2 more floors. In the meantime, the team descends and rests while waiting to carry and pass on additional equipment. While this method requires a large number of firefighters, it is an option available to supply needed resources to the fire attack area. Newer high-rise buildings have enclosed pressurized stairwells designed to provide the occupants and firefighters a smoke-free environment while moving within the stairwell. The basic principle of a pressurized stairwell is to enclose the stairwell tightly, and then to add a fan to increase the air pressure inside the stairwell. So when the door or doors to enter the various floors are open, the air pressure inside the stairwell will push the smoke back and keep the smoke in the floor area. In some systems, if too many doors are open at the same time, the pressure reduces to a point that the stairwell fills with smoke. Fire department fans can supplement the pressure in the stairwell if needed. Important tactical considerations with fires in high-rises is the reliance of fire departments on built-in systems to assist the fire control and extinguishment. Building systems available to firefighters are standpipes, sprinkler and water supply systems, fire pumps, fire communications and command systems, and pressurized stairwells. These systems are varied and can be complex. Fire departments must master their use in order to bring fire operations to a successful conclusion. A closer look during pre-incident planning at some of the systems found in high-rise buildings is needed so that these systems can be employed properly during fire operations. Most building codes require standpipe systems in high-rise buildings. Although some buildings are not technically considered high-rise buildings, they should be defined as such for firefighting purposes, as the fire service cannot reach the interior of the building from ladders. As discussed earlier, this definition would include buildings that have stories beyond the reach of available ladders. One way to better understand standpipes is to look at them as water mains that are built into the building with an outlet. These fire hydrants are located in the stairwell of every floor. Firefighters connect into the hydrant and advance the hose line into the fire floor from the stairwell. On the outside of the building, the standpipe connections is where the fire pumper connects to the pressurized water main. Pre-incident training exercises are a good way to determine if a building has a workable standpipe system. Because the fire pumper is set to 1 pressure, and the pressure at each floor will vary and in some cases be too high for firefighters to control. Therefore, in some cases, a pressure reducer will be needed to be installed. Firefighters must ensure their operation and their pressure is correctly set during the pre-incident planning session. Here's a picture of a fire department connection and a post valve indicator. Notice the target indicating the valve is open and the attached alarm system to notify when the valve is closed. Most new high-rise buildings are equipped with fire sprinklers. Because of the height of these buildings, many of the systems are installed in high-rises in zones so that fire pumps can provide sufficient water pressure. When properly installed and maintained, fire sprinkling systems can quickly control and extinguish most fires with water from 2 or less heads. All high-rise buildings are required to have auxiliary fire pumps designed to increase the pressure in the sprinkler and/or standpipe systems. These pumps can be found singularly or in pairs. They are designed to start when the pressure drops. Then a sprinkler head or standpipe valve is opened, decreasing the pressure in the pipe. The pressure decrease causes a switch on the pump to note the drop in pressure and starts the pump. Although some systems may be more complex than others, the firefighter should know how to operate it and to have a basic understanding of fire pumps. It is essential that the inlet and discharge gauges be checked, and it is critical that the bypass valve left closed after pump testing. 50% of the pump capacity can be lost with an open bypass valve. In most post-fire reviews for high-rise building fires, the issue of poor fireground communication is most often raised. The reason is that high-rise buildings are built with steel columns and beams, enclosed with concrete, which absorbs much of the energy from the fire department radio communication systems. In many cases, the steel and concrete enclosure makes emergency communication totally ineffective. To resolve this problem, newer high-rise buildings have communication systems built into the structure. These installed communication systems use hardwiring that allows intra-building communications using a series of high reliable speakers and telephone devices located throughout the building. The system allows for the fire department to direct occupants during the evacuation process and allows the incident commander to speak directly to the operations and division chiefs. The key to successful search and rescue efforts in high-rise buildings is the same as other buildings. Establish a systematic search method to ensure all areas are checked for remaining occupants and set up an accountability system to account for those found and those missing. Firefighters need to be aware of a behavior called convergence cluster behavior. This was first observed in 1989 at the Las Vegas MGM Grand Hotel fire. Convergence cluster behavior occurs when occupants feeling threatened by fire converge together to feel safer in the presence of others. This results in a group in one area or room, rather than people waiting for rescue in their separate rooms. On some fires, firefighters have wasted time and effort searching vacant rooms, only to find all persons gathered in one location. An accountability system is needed to verify the whereabouts of all occupants. Total evacuation of high-rise structures during firefighter operations is generally neither practical nor feasible. The primary effort depends on the number of people needed to be moved, how they can be moved, and if a safe refuge area is available within the structure. An example of this is providing safe areas or zones in hospitals, as patients can be moved horizontally to another safe zone within the building. High-rise office buildings, hotels, and apartments typically have valuable contents, such as computers, office equipment, business records, and personal items. The owners and occupants may request assistance in obtaining these items. When, and if possible, it is important for good community relations to make every attempt to assist these individuals. The height of the building comes into play in an opposite way when we consider property conservation. In life safety and fire extinguishment, people in property above the fire are normally considered to be the most at risk. Fire, smoke, and heat will first affect materials on the fire floor and the floors above. However, the greatest need for property protection is generally downward, as water flows through stairs, walls, utility chases, electrical fixtures, and other openings, damaging and destroying more property beneath the fire. In addition to protecting valuables with covers, firefighters should channel the flow of water down the stairs or through drains. Like life safety and fireground operations, property conservation operations must be well planned and systematically executed to reduce loss. Overhaul of high-rise buildings is labor-intensive. A good pre-planned incident helps determine where to direct initial overhaul efforts. The pre-incident plan can direct firefighting forces to hidden shafts that need to be thoroughly checked, as well as false ceilings, which should either be pulled down or opened so areas above them can be checked for fire extension. Crews should be assigned to every floor above the fire to check for smoke and possible extension. Additionally, crews should check areas below the fire to verify complete extinguishment. High-rise fires in the United States are becoming an increased and significant fire life safety problem. Looking at the U.S. statistics for fatal high-rise fires in offices, hotels, and apartments, there were more fatal fires annually in apartment high-rises than in office and hotel high-rises. The hotel and office building fires get the most attention because a large number of people are often killed in a single incident. There are a number of significant differences between ordinary structure fires and high-rise structures that make firefighting in these fires difficult. Almost universally, the communications inside them is poor. The height of the building inhibits the use of ground ladders for easy entry into the upper portions of the building, and the use of elevators is dangerous if the proper safety procedures are not used. Ventilation of enclosed high-rise buildings is another problem, when the movement of hot fire gases can spread into areas not affected by the original fire if ventilation is not properly conducted. Firefighters need to be aware and know how to operate special equipment found in high-rise buildings. Special attention needs to be given to determine if convergence cluster behavior is occurring and if problems related to evacuation can be resolved by relocation. Salvage and overhaul operations will need special attention and careful planning to reduce smoke and water losses. And this concludes Chapter 7, High-Rise Building Fires. Thank you.